Now let me run only this one. It's actually using a neural network toolbox. Now see here, this is how a network is going to look like. As I said, one input, because here I have given 1 and the number of layers is 2. So it's a layer 1, layer 2, and then finally we have the output. So this is how a network is, okay? And then we have taken here 1, 0, which means that for the first layer you have a bias, and for the second layer there is no bias. So that is what here 1 semicolon 0. So which means that for the first layer you have a bias, and for the second layer you don't have a bias. So if you see in this network, for the first layer there is B, that bias, and the second layer there is no bias here. And the input connect. So again here the input connect 1, 0. So which means that input is connected to the first layer and is not being connected to the second layer, because output of the first layer is the input to the second layer. And then if you see here the layer connect. Okay, so here this layer is the first layer output is connected to the second layer, and the output of second layer is connected to the output. Okay, and here the last one is nothing but output connect. Again, this is nothing but the first layer is not connected and the second layer is connected to the output. So that is why it is 0, 1. Okay, so 0 is nothing but the first layer not connected to the output, and this is the second layer. If you give 1, it says that it is being connected to the output. Okay, and this is 0, 0. So this is which means that the input is connected to the first layer and the layer 1 is connected to the layer 2. So it's a layer connect, and this is input connect, and this is a output connect. So this is how we have to define a network. So you can decide your number of layers, number of neurons, and everything here. Okay, let me tell you how to decide the number of neurons and all those things. So it's a simple network what I've created here. We haven't given any functions here to make it activated. Now if you see here, I'm going to fix the number of hidden layer neurons. So here, if you see that keyword for giving that is net dot layers of 1 in the layer 1, because we have 2 layers here, layer 1 and layer 2. So if you are going to fix 5 neurons in the first layer, you have to give here net dot layers of 1 dot size is equal to 5, which means that we are going to have 5 neurons in the first layer. And then we have to decide what is it function is. So because the hidden layer output is given to the the function, activation function, and the output is being generated. So now I'm going to define what is this layer transfer functions, because we have so many transfer functions here. The activation function is hard, limit, pure, linear, log sigma, tag sigma, and relu. All those things are different activation functions. So you have to define the activation function. The keyword is net dot layers 1 dot transfer FCN. Function is log sigma. I'm taking here. You can vary this activation function. You have a keyword again. So now you have to view the let us view the network now. Now see here, in the previous when I run it, I had only the network with 0. So because there is no neurons I have assigned. But if you see here, this is the first thing, the first network. So 0, 0, 0, everything is 0 here. But if you see the second one, so I have defined the transfer function. Linearly by default, it takes the linear function here in both the layers. But after defining that for log sigmoid function here, if you change the network, if you view the network, it gives you 5, which means that the number of neurons here is 5, and the activation function is going to be a log sigmoidal function. So that sigmoidal function, the graph is changed here.